Good morning. So let us get into the revision of Module 4. So probably before we get into that, hope you all have the access to the notes what is shared with you. So probably you should let me know what are the topics where you have some confusion, which we can brush up. So to start with, let us begin with the definition or concept of a macro processor. Is that right? Is that okay? Okay.
Yes, sir.
So macro processor, we have been talking about macros in high level languages, and macros have a definite purpose, which is very specific in nature or unique in nature, wherein a macro represents a small body of a program, a small entity of a program in general, which is used for two purposes. One, to make the program more readable. Second, to provide the facility wherein a commonly used data can be grouped as a macro and any changes can be done at one place rather than doing the entire program wherever the data is used. The best example can be pi, the value of pi in mathematics. Suppose you are working on a mathematical program where you are going to calculate the area, perimeter and circumference, whatever it is, where you will be using pi in every formula. So normally what we can do, we know the value of pi 3.14. One practice is go to the formula, wherever area of circle, area of triangle, area of semicircle, all those things where we are using 3.14 into radius, like that we can write. That is normal or a regular way of doing that. But what is the problem with that process is, suppose somebody asks you, okay, 3.14 is very small, make it 3.1423. That means extend the precision by 2 more points. Then what we have to do? We have to search wherever 3.14 is used, go back to the program and start replacing 3.14 by 3.1423. So during this process, two things might happen. One, you might miss some of the places where 3.14 is written, which is not in the right spirit of the program. Second, while typing, you may do some mistake. Instead of 3.1423, you may type something because typing errors are possible. So in both the cases, you are going to get an answer which is not as expected. So you may put yourself in an erroneous situation. So what is the solution for this? A solution for such type of activities where a commonly used data is represented in terms of macros, or which is going to be frequently used in a program in a better way, is what we require. That is coming through the concept of a macro. So what is the solution now here? So instead of 3.14 being used as it is in the program, we declare a macro using hash define in C or C++, where pi 3.14. So in future, whenever the program is requiring value of pi, you simply write pi. It serves two purposes. When you go to the program, you feel the formula is as it is, pi r square, pi 2 pi r. So you see that value being used in terms of the macro will resemble the formula what you remember. So confusion is reduced or avoided. Second, you want to change 3.14 to 3.1423, just to go to the beginning of the program where you have defined the macro, where 3.14 is there, add 2, 3 after 4, purpose is done. So it is going to solve the problems what you have just seen. That is, erroneously typing some value in the place of 3.1423 is avoided, straightforward. Second, missing the values of 3.14 because you have used it at multiple places. Both of them are being avoided. So macros are going to be handy tool for a programmer when a small content which is repeatedly used is required to be taken into the program, then better to go for a macro. This is with respect to the data. So coming to the functions as well, we can use the same macro for performing certain functionality. Best example, again, regular example, what we take, square of a number. So what is the square of a number? 2 into 2, 4 into 4, 5 into 5. So when I give a number, say x, I need to take the square of it or cube of it, whatever it is. If it is a square, item into item, x into x. If it is a cube, 3 times x into x into x. So depending upon that, we can write the program or maybe a macro at one place. I can simply use square square, wherever I want. So that's how it is going to be used. So macros are not only for data, they're also there for the functions. In fact, macros have been coined with the purpose of a functionality. Then what is the difference between a macro and a function? No doubt, macros are a small set of a function which you see user-defined function, but definitely there is a sea of difference between a macro and a function. What is that? As we know, macro is meant for a specific purpose. Of course, function is also meant for a specific purpose. But the difference here is majorly, whenever macro is designed, it is said that we should not give more functionality to the macro. Maybe 1 line or 2 line, maximum 3 line, not more than that. Whereas in the case of a function is going to be used with any number of lines without any restriction. And of course, you should be writing a specific function. That's all the requirement. So apart from this, since we have a very small number of program constructs or lines in the macro, whenever a macro is called, macro call is replaced by the body of the macro. This is the key difference between a macro and function. That means whenever a macro is called, wherever the macro call is there, that particular place gets replaced by the body of the program. For example, if you take a square, square is defined as SQR within parenthesis X. If I give 10, what it will happen? Square means 10 into 10. So if I define square of X as X into X, wherever I call square 10, you will not see square 10 function here, mean macro. You will see instead of that, X becomes 10, so 10 into 10. So wherever square X is called, then it will be 10 into 10, 20 into 20, 5 into 5, depending upon the actual parameter what you have used. But the contrast to that, in function, what will happen? When you call a function, which is user-defined function or any system-oriented function, the control will be passed from the calling function to the called function using your link register concept. Called function gets executed and returns back to the calling function and execution continues. So this is the key difference between macro and a function. When macro is called, macro call is expanded with the content of the macro definition. Whereas in the case of a function is not going to expand as we do in macro, but function call is separately taken, executed, comes back. Both of them have their own purpose. A function is coined in such that whenever I want to do a particular task repeatedly with a set of group of instructions without disturbing my main flow of the program, so probably we can write a function. Similarly here, macro is designed or coined in such a way that a small set of data which you want to repeat not 100 times, maybe it's 10 times or 15 times. Whereas a function, you can repeat any number of times, more will be the merrier. So that is the major difference between a macro and a function. So is that clear? Where we are and how macro differs from a function. This is the beginning to understand what a macro is. Any doubts at this point?
No, sir.
Okay. Fine. Now let me know where the doubts you have in macro processor. So what was the concern? Where you're not able to understand? So this is the background. So which concept is bothering you? If you tell, we shall discuss.
Sir, my macro processor algorithm and data structures, sir.
Okay. Fine. Up to that is okay?
Yeah, sir, fine.
Okay. hope the screen is visible. Yes. Microprocessor algorithm. So the basic requirements for this is you should know better what is the definition, what is a macro call, and what is a macro expansion. So a quick review of that. Macro definition is a one which starts with the keyword macro and ends with MEND, another keyword, which is both are assembly directives that defines the macro definition part. And also macro definition, after macro name, we have a set of parameters which are prefixed with ampersand that precisely talks about it is a definition stage. Then when is a macro call, you just call the whatever the macro we have. So that is a call for a macro with actual parameters. And third one is a macro expansion. So wherever there is a macro call, actual parameters will be replacing the formal parameters and body of the macro gets expanded exactly at the place where macro is called. So with this introduction, let us get into the macro processor algorithm or data structures. So we have been talking about a 2-pass assembler, 2-pass linker loader. In the same lines, we have a 2-pass macro processor. In one of the exam, as we've seen in the previous class, they've asked about a 1-pass macro processor. Now it is not wise for you to think too much about a 1-pass macro processor. You can continue with the 2-pass, and wherever possible, you can talk about that particular pass one, but don't waste your time. Even if it is asked in examination, 1-pass assembler or 1-pass algorithm, normally they should not be asking, because you cannot imagine in the exam and write, because that is not there in syllabus. So wherever algorithm is asked, it is always a 2-pass, maybe an assembler, maybe a linker loader, or a macro processor. So you need not debate or need not waste your time. Even if somebody asks as a 1-pass macro processor, it is not advised. Okay? You can go ahead with whatever we have. Next, so coming to the data structure, so any algorithm requires some data structures. We have seen op tab and symbol table in assembler. We have seen ESTAB in the linker loader. Now we see 3 data structures to facilitate the macro processor. What are they? They precisely into name table, that where the names of the macros will be stored, but not only names, along with the name tab, along with the names of the macro, the pointers, because you are going to expand the macro later. So to expand the macro, someone has to hold. When I have multiple macros being defined in a particular program, there should be some what you call delimiter, which says that which is the beginning of the macro body, which is the end of the macro body. So 2 pointers are associated with every macro name, such that whenever that particular macro is called, during that particular delimiter or pointer, whatever the content is there, that verbatim exactly gets copied into the macro call. So for that purpose, name tab is going to contain the name of the macro along with 2 pointers. Those 2 pointers precisely talk about the beginning of the macro body and the end of the macro body. After that, we have a definition table. As the name says, definition, macro definition, that is a macro body, will be part of it. And argument table, as we know, every macro definition has certain formal parameters, and these formal parameters need to be replaced at the time of a macro expansion. All those actual parameters that have been passed during the macro call are stored in the argument table. These are the 3 precise data structures we have with respect to the macro processor. Coming to the algorithm now, this is a diagram which we can visualize. So name table, we have a name of the macro, 2 pointers, and first pointer for the beginning, second pointer for the end. This RT-buff MEND has been given for us to understand this is the beginning and end. So this is the definition table. And what we can observe here is, in the definition table, when you see the macro parameters here, ampersand and all, they have been given numbers. What are the numbers? INDEV is 1, buff address is 2, RECLTH is 3. So in the program somewhere you see question mark 1, question mark 2, question mark 3. So this question mark 1, question mark 2, question mark 3 corresponds to first argument, second argument, and third argument. That is only given for the understanding purpose, not to repeat the same names again and again. That's the concept what we have to see here. And coming to the argument table, which contains the actual parameters. See, they are not having any formal parameters. Formal parameters are INDEV, by BU of ADR or EC length. But what we have F1 buffer length. That means this contains the actual parameters. So argument table contains actual parameters, definition table contains actual definition, and name table contains the actual name of the macro along with the pointers. Okay. So coming back to the algorithm now, algorithm has been defined into, or I would say designed into 5 different modules, just to make sure that everything is considered here. So first, let us see the macro processor, the main algorithm or pseudocode. So first, and every macro processor, what is the point now? Macro definition is already there. Macro expansion need to be taken care, and it has to be converted into whatever the revised program what we have. So pass 1 as well as pass 2. So in this case now, initially we are making expanding false, because our first duty is to fill up the definition table and name table. So that's what we have to see. So that is the first iteration. So expansion will not be coming now. As a purpose, we are going to make expanding as a false. This is a flag now. So as long as we have not reached the end of the program, what we have to do, read every line from the beginning of the program till the end, process that. This process can be either storing into name table or storing into definition table or processing using the expansion. So this will be expanded later. Otherwise, we'll go to the end of the program. That becomes the end of. This is the main or a overall or a supreme pseudocode for the main macro processor, or a general pseudocode. What is that? Initially, we are not doing expanding. That's why it is made as a false. From line 1 till we go to the end of the line, that is END, we have to read every line, process that. Read every line, process that. Read every line, process that. That is the maximum or the major work. In process, we'll see what is going to be done. So this is the topmost pseudocode or the algorithm what we have for the macro processor. Okay. Now, let us go to the get line before we come to the process line. So get line. So what is a get line now? So we are going to get the line. That means each line need to be taken care. So when you take the each line, this line is required for both the passes. That is pass 1 as well as pass 2. When you read for pass 1, we need to store that in the definition table. When you read it for the second time, we need to store it in the expansion. That is expand the program. That is a revised program. So for that purpose, we are checking if expanding is true. That means first case we made it as a false. That is in pass 1. Let us see get line from pass 1 perspective. In pass 1, it is made as a false. So it is not going to come to the if. It will come to the else part. That means it keeps on reading the data one by one, one by one, one by one. Okay. So if it is next step, that is a pass 2, where expanding is true, wherein whenever there is a call, we need to come back here and make sure that expansion is done. Then what we have to do, every line in the macro definition, that is what is available in the definition table, need to be stored into the revised file along with the actual parameters that are part of the argument table. That's what we are going to do in the get line process. So get line has 2 purposes. If it is a pass 1, it will simply copy the line which is a direct line, because which is not part of a macro. If it is a macro expansion, that is in the second pass, it is going to take care that whatever the body of macro is there from definition table, that will be copied verbatim into your expansion along with the actual parameters. So that is the get line. So now let us go to the next step, which is a process. As we know, process is a multiple variety or multiple subprograms, wherein we need to take care of the pass 1 as well as pass 2, as we did in the get line. So now, so while going to the process line in the pass 1, let us say, we are going to check whether the whatever the macro we have defined already is part of name table already. This we did in the symbol table as well. Whenever a new symbol comes, we used to check whether the symbol is available or not. If it is already available, will not be duplicating. If it is not available, then only we used to push it into the table. In the same case, we are going to search if name table is there. I mean, if the whatever the macro we have used is available as part of the opcode or not. If you look at the macro definition, the macro definition part is name of the macro as a assembly directive followed by parameters. So that macro MACRO is a part of the opcode when it is a macro definition. During the macro definition, name of the macro is available as a label but not as a opcode. But when it comes to the macro expansion or a macro call rather, the name of the macro will be available in the macro opcode. That means depending upon the place where the name of the macro is used, we can decide whether we are at the definition stage or we are at the macro invocation stage, right? If the macro name is available under label, it is a macro definition stage. If macro name is available in the opcode stage, it is a macro expansion stage. So we have started the program with expanding as a false. Now we have to take a call whether we are working on a macro definition or if we are working on a macro expansion. So that's the reason why we are searching name table for an opcode. That means if opcode is containing the name of the macro, meaning that it is the macro invocation or a macro call, then I need to check whether that name is available in the name table. If it is available, then I need to expand. That means I need to expand because it is a macro call. If not, that means I have a opcode which is not having the name of the macro, then I need not search for a name table. Then what I will do now, I will check if it is a macro. That means if opcode is a macro, if opcode is a macro, it is nothing but it is a macro definition, then I will go to the definition table and do that. Else, it is not expansion. That is, there is no macro name in the opcode. There is no macro assembler directive in the opcode. Then it will be something else other than the macro processor. Then I will simply store that into the actual file. I am not going to do anything with respect to those two. That is another concept that is during the process line. So process again, you have to see whether it is a pass 1 or a pass 2. If it is a pass 2, expansion will come into picture. If it is a pass 1, definition will come into picture. Now let us see what is expand and what is define. Any doubts up to this? We started with the macro.
No, sir.
Yeah, fine. We started with the macro processor. We assumed expanding is false. Two things will happen in pass 1, pass 2. One is the get line, process line. In get line also again, two things. If it is a pass 1, we are going to simply store everything into the revised program, or we'll be keep. If it is a pass 2, then we'll be expanding that, making expanding is equal to true. Similarly, when it comes to the process line, again pass 1, pass 2. If it is a pass 1, we'll define the program in the definition section, or if it is not true, then pass 2, then we expand the program. That is the macro call. Let us see what is expand and define. So let us go to define because it is a pass 1. So define means we are going to enter the data into the def tab. So now def tab, both name tab will be used here because first time. So macro name will be part of the name table and macro prototype or the body will be stored into the definition table. But here there might be possibility that we can have a nested macro. So this algorithm is also meant for a nested macro. So in the examination, probably if you find it difficult or not able to write, you can skip some of the levels because levels are going to talk about as a nested macro. If you don't want to write nested macro, we can restrict your program into single level and make sure maybe when they ask about a pass 1, we can avoid these levels because in pass 1, levels cannot be processed properly. So we can stop it. So you can take a call in the definition section. If you feel it is too big or not able to write in the given time, probably we can take a call on reducing the levels. Otherwise, we can go to the next step called a get line and thing stuff. But let us understand with the levels. Assuming we have a macro with multiple levels, which is a nested call. So we know that as and when macro contains another macro within it, so macros like your inheritance and destruction in the construction destruction in your OOP concept, as a constructor is called, the level will increase. As a destructor is called, level will decrease. In the same process, as you see macro, the number of levels will be increased. As you see amend, the number of levels will be decreased. So that means there will be matching for every macro and amend, macro and amend. So whenever you see macro, number of levels will get incremented. Whenever you see amend, number of levels will be decremented. So you also seen in the OOP, whenever in the concept of a program, when a constructor is called within the what you call nested level of constructors. A constructor will get increment, the number will be incremented. Whenever destructor is called, number will be decremented, again to match them. So same concept here. So level 1 we are initializing. If level is greater than 0, meaning that we have more levels, more values are there, so we'll go with that. So assuming initially level itself is 1, of course it is more than 1, we'll get into that. What is the get line now? In get line we have just now seen there are two processes. One is a pass 1 and pass 2. If it is a pass 1, we just copy as it is. If it is a pass 2, we go to the expansion. Since we are in pass 1, we just take the line as it is. So if that line is a comment line, we will not do anything. If that line has, let us say, opcode macro or opcode mn, accordingly levels will be incremented or decremented, and accordingly the definition table will be updated, and name tab will be updated at the end because it need to contain the beginning pointer and the ending pointer. So this is what we are going to have with respect to a definition table. So any doubt here?
No, sir.
Good morning, madam. I will call in half an hour. I am in the middle of the class. I will call in half an hour. Good morning, madam. Shall I call in half an hour, madam? I am middle of the class. I will call. Yeah. Okay. Sorry, I had a call. Fine. This is about the definition section. Now let us see the pending section, which is a expand what we have to do at the, for every macro column. So now expand is required. Obviously, when expand is required, expand need to be made true. Again here, when expand is true, the data what is there in the definition table will be key for us along with the argument table. So two data structures we need here is a definition table and argument table. So every time when there is a macro, we'll get the line which in the body of the macro definition, and that line will be processed further to enter into the revised file. So once processing is over, we have to make sure that expansion is made false, because the get line process line contains both non-expanding mode as well as expanding mode. So you should be very careful. Once expanding is made true internally and expansion is over, then we have to bring it back to the normal, that is expanding is false, so that next line will be processed without any problem. So that's how we are going to complete the process of a macro definition, macro call, and macro expansion, for which we have 5 different small subgroups. Where is one is the top program. Second, we have a get line, we have a process line, we have a define, we have a expand. So these are the 5 different subprograms we have for the macro algorithm. So probably a couple of iterations, if you go through that, you should be able to understand the flow properly. So hope this has given some input to you, and still if you have any doubts, please let me know. Any doubts?
Sir, Arjun, sir.
Tell Arjun.
Sir, in pass 1, we just copy as it is. In pass 2, we have to expand, right, sir?
Pass 1?
We have to write as it is. We have to copy, right, sir?
Pass 1?
Yeah, sir. In pass 1, we have to write as it is. In pass 2, we have to expand, sir.
No, as it is means this is algorithm. Algorithm will take care that pass 1. So normally in assembler, what you have seen, you write an intermediate program, then that is going to be given to pass 2. The same process here. Pass 1 will not be doing much activity unless we update the name table and definition table, right? So using pass 1, that get line or process will help us to fill up the name table and definition table. That's all.
Yes, sir.
Not going to do much with respect to the main program. So main program is not disturbed. So that's what if you get anything other than macro definition or macro definition, you will not be doing anything. Just copy as it is. That's what we have algorithm as well, right?
Yes, sir.
Anything else? Okay, what is the next case? Next point where next doubt?
No doubt, sir.
So module 4 is over. That's all.
Sir, generation of unique labels. ಒಂದ್ಸತಿ brief ಮಾಡ್ತೀರಾ?
Okay. Is the screen visible?
Yes, sir.
The concept of generation of unique labels comes with the requirement that in a macro is a subset of your program, right? So that can also have a label. So when I have a label in the macro, if you call that particular macro for once, I have no issue. But macros are meant for subsequent calls. A macro can be called more than once. When a macro is called more than once, assume the situation where that macro contains a label. If macro does not contain a label, we have no issue absolutely. But the problem arises when the macro has at least one label and that macro is called more than once. These are the 2 points where we have an issue. First point is macro contains a label, and second, that macro is called more than once. When these 2 things are happening in a given program, then we need to look at the generation of unique labels. So why we need to do that? Let us see what happens. Assume I have a macro as we defined here. This has a loop as one of the label. And I am going to call this macro ADD 2 times. I will call ADD 10, 20, 30. Next I will call ADD 100, 200, 300. So you know that just now we have seen the algorithm. Before execution, what will happen? The macro gets expanded. So when macro gets expanded for the call ADD 10, 20, 30, it will be LDA 20, ADD 100, 30, comparison 3, JLT. This is the body. Again, I have another macro ADD 100, 200, 300. Again, LDA will be 100, ADD will be 200, compare 3, JLT. But what is common between these 2 expansions is LOOP. That LOOP is the same. Now, when we get the same LOOP at 2 places, obviously there is a confusion for the program at the time of execution. What is the confusion? When I am at line number 2, let us say ADD 20, I have a loop, and at the same time, after 5-6 lines, I have another ADD which is having number 200, which is also having the label LOOP. Now, when I am at line number 2, when LOOP it says, line number 4, JLT LOOP, it will have a confusion whether to go to line number 2 or line number 7 or 8. So that confusion makes the program to break there. So it will say it is unambiguous, it is ambiguous, and hence it is not able to process because same name is there and there is no clarity for the JLT whether to go to line number 2, line number 8. That is coming because we have used that label in a macro and macro is expanded more than once. So that is the reason why we have to generate unique labels when there is a macro expansion. Is it clear now, the problem? Yeah. Now what is the solution? Solution is, now while you write a macro with a label, we don't know whether it is going to be called once or twice. Why to take risk? Let us enable this to have a unique labels. How do we do that now? Instead of simply loop, you prefix with a dollar symbol. Instead of simply loop, we prefix with a dollar symbol. So what is going to happen now? This dollar symbol will remind the expansion that, look, whenever there is a expansion for this particular macro, you need to replace the loop with some unique labels. What are the labels? Prefix with $AA, $AB, $AC, $AD, like that up to $ZZ. Then if ABCD is over, then $A0, A1, A2, A9, like that, 36 combinations, totally resulting up to 1296, meaning that a macro can be invoked 1296 times without any ambiguity. And normally in practical, we'll never do that because macros are meant for what? Maybe calling once or twice or thrice, not beyond that. But flexibility has been given in the program such that we can go beyond 1200 times. So how it is being done now? You have to prefix every label name with a dollar. As and when expansion takes place, the dollar gets replaced with $AA, $AB, $AC, which is a unique value. Thereby, confusion will not be there. So that is the idea with which generation of unique labels are there, which are going to remove the ambiguity at the time of expansion whenever a macro contains label and gets expanded more than once. So that is the idea behind generation of unique labels. Is it clear?
Yes, sir, it's clear now.
Yeah. Anything else? Okay, what else in macros? Macro processor, module 4. Concatenation of macro parameters, keyword macro parameters, recursive macro definition, all these things are important. Let me take attendance meanwhile. You can think and let me know if you have any doubts. Asta?
Present, sir.
Abhinav? Aishwarya?
Present, sir.
Ambrish? Anu?
Yes, sir.
Present. Present.
Arbaz? Arbaz? Arjun?
Present, sir.
Ashok?
Present, sir.
Vinita?
Present, sir.
Bhargavi?
Present, sir.
Pavisha?
Sir.
Chaitra?
Present, sir.
Chatterjee? Diksha?
Present, sir.
Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Murali Krishna?
Present, sir.
Gangubai?
Present, sir.
Kuriya Kumari? Arshit?
Present, sir.
Chunjar Singh? Kavya?
Present, sir.
Kishore? Lata?
Yes, sir.
Manisha?
Present, sir.
Manjunath?
Yes, sir.
Nayana?
Present, sir.
Nilanjan?
Yes, sir.
Nishant? Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka?
Present, sir.
Pawan Kumar? Akash?
Present, sir.
Rajeshwari?
Present, sir.
Rakesh,
Present, sir.
Ramya,
Present, sir.
Rashmi,
Present, sir.
Ravisankar, Rizwan,
Present, sir.
Vishal,
Present, sir.
Savita,
Yes, sir.
Shruti, Sneha,
Yes, sir.
Spurti,
Present, sir.
Srinidhi,
Present, sir.
Srinivas, Sunil,
Present, sir.
Vaishnavi,
Present, sir.
Vinny.
Present, sir.
Okay.
Sir, Gudiya present.
Sir, BY24 present, sir.
So let me know the doubts. If you don't,
TD 16 present, sir.
which number?
Sir, TD 16.
Shruti.
Yes, sir.
Okay. So let me know any doubts, or else we can wind up today. We'll meet again for module 5. So if, before that, if you have any other doubts, you can let me know. So today we'll see module 4. So hope all of you could submit assignments, but I have a list of people who have not submitted. So you all know I need not tell the names. So you know marks will be reduced if you submit late, which is already late for some of you. So now it is time for you to complete assignments and send. If you don't send, you lose those marks, obviously. Fine. If you don't have any doubts in module 4, probably we can wind up. So at the same time, take care of yourself, because pandemic is not leaving us. It is still coming with a different mode. So it is advised all of you to not to be complacent and take care of yourself with all your earlier precautions, maybe wearing mask or sanitizer or taking care of yourselves. So all the best. Take care. We'll meet tomorrow. Thank you.
Thank you, sir.